How fast can I explain the basics of pulley systems? We're about to find out. So let's start with this problem right here where we have two masses that oppose each other on a pulley. One of the objects is on an incline, the other object hangs off the edge. We're trying to find the direction that the system moves. So I need an equation that represents the force due to gravity of both objects. And the two equations I need are these two equations right here, where this represents the mass of the 80 kilogram object and m prime represents the mass of the 100 kilogram objects. I'm going to start by calculating the weight force of the 80 kilogram object. We have m times g, which is going to be 80 kilograms times 9.8 meters per second squared. This is gravitational acceleration on Earth. 80 times 9.8 should give you 784 newtons. Now let's calculate the force due to gravity of the 100 kilogram object. That's going to be m prime times g times the sine of theta, which should give you 100 times 9.8 times the sine of 65. Evaluating this entire number right here should give you 888 newtons. Notice that 888 newtons is stronger than 784 newtons. That means the system's going to move to the right. Problem 2. What is the acceleration of this system? So notice in this problem we're given a coefficient of friction, but we're also given that the system is moving to the right. We're going to have a frictional force which acts on this object since the system's moving. Frictional force always opposes the motion of the object. Since we're on a flat plane though, and we're not on any kind of incline, we can get rid of this cosine theta here. Now to calculate weight force is just going to be the mass of the object times gravitational acceleration. M prime represents the 10 kilogram object, whereas m represents the 20 kilogram object. I'm first going to evaluate the weight force of this object, which is just going to be 10 times 9.8 since we have a 10 kilogram object, so you should get 98 newtons. Now let's calculate the frictional force. We have the coefficient of friction, which is 0.2 times m, which is 20, and then gravitational acceleration is 9.8 meters per second squared. So 0.2 times 20 times 9.8 should give you 39.2 newtons. Now to calculate acceleration of the system, it's going to be the sum of forces over total mass. So in this case, we're going to have 98 minus 39.2 divided by 30. Now the reason we're subtracting these two values is because notice this force is going to try to oppose the motion of the system. So in this case we need to make this force negative right here. 98 minus 39.2 divided by 30 should give you 1.96 meters per second squared. And that's the acceleration of the system and the answer to problem 2. Problem 3. Calculate the tension in the rope. So to find tension in the rope, we first need to determine the direction. Now I can tell just intuitively this system is going to rotate towards the 8 kilogram object since that object is heavier. What I can do is take this acceleration here and I can write it like this. Now the equation that will give us tension force is going to be the weight force plus the net force at one specific point. Personally for me, I'm going to use the 8 kilogram object. So we need to find the weight force plus the net force of the 8 kilogram object, which is going to be mg plus ma. The mass is just going to be 8 kilograms. G is going to be 9.8 meters per second squared. Acceleration is going to be this negative 4.45 meters per second squared. So plugging everything in, you should get 8 times 9.8 plus 8 times negative 4.45. Now if you evaluate this entire equation right here, you should end up with a total tension force of 42.8 newtons. But notice here that this rope is the same throughout this pulley system, which means the same tension force is going to be acting on the pulley over here. So 42.8 newtons is the tension in the rope, and that was a basic review of pulley systems.